Hi, this is Mark of ChanceBot.com. Thanks for tuning in. The purpose of this video is to provide a basic explanation of how ChanceBot works and to show some of the mathematics that drive the simulations. I'll point out that you don't have to watch this video to use the site. This is really just for folks who want to gain a slightly deeper understanding of how the site works and how the numbers are derived. The basic idea of ChanceBot is to establish outcome probabilities for all the remaining unplayed games in a season, and then use those outcome probabilities to create a set of aggregate probabilities for the rest of the season for things like to see who comes in first place, to see who makes playoffs, etc. In other words, if we can accurately peg how likely each team is to win each of the rest of their games, we can combine all of those probabilities to determine how likely a team is to come in first place, as I said, or to make the playoffs. So probably the easiest way to think about this is to consider two hypothetical teams. We'll call them red and blue. And let's say that there's one game left in a season where blue plays a third team called green. And we'll assume that for the purpose of the example that if blue defeats green, blue will come in first place in the league. But if green defeats blue, then red finishes in first place. In this simple case, the outcome probability for blue in this game is equal to the probability that they will achieve first place in the league. So in this basic example, we'll show them with a 60% chance of winning the game and therefore a 60% chance of coming in first place. Likewise, or on the other hand, green has a 40% chance of winning the game and therefore red has a 40% chance of coming in first place. Okay, now we can blow this up a little bit and look at a case where each team has one game remaining. Blue is still playing green, but now red has a game against orange. In this example, we're going to assume that the only way that red can finish in first place is if they defeat orange and green defeats blue. Okay, so we'll leave the probability for blue to defeat green is the same at 0.6, and we'll set red's outcome probability, just to make it interesting, at 0.8. Now, if you look at this table, there are 4 different outcomes that can occur. Both teams can win, both teams can lose, red can win and blue can lose, or blue can win and red can lose. And each of these outcomes has a probability unto itself. If the games were 50-50, if they were pure toss-ups, then the likelihood of any of these outcomes occurring would be 25% each. Now, just to go over how the percent value at the top of each column is calculated, it's basic probability, but I'll just give a quick review here. If you look at the 48% value, what that represents is the probability that both teams win. Now, to calculate the probability that both teams win, all we do is simply multiply together the probabilities that each team will win. In other words, red has an 80% chance of winning and blue has a 60% chance of winning. We multiply those percentages together and we come up with 48%. Likewise, to calculate the probability that both teams will lose, we take the probability for each team that they will lose their game and we multiply those together, and that gives us 8%. So in this case, we end up with 3 ways that blue can make the playoffs. Both teams win, both teams lose, or blue wins and red loses. And that totals to 68%. The only way that red can make the playoffs is if they win and blue loses. Now, if we wanted to, we could include more games as needed for a deeper analysis. But each game that we add doubles the number of columns in the resulting table. And it actually doesn't take long for this doubling to overwhelm the computational power of even a very fast computer. For instance, the National Football League regular season consists of 256 games. This is actually the shortest professional sports season in North America. Even that, if we did a full analysis for the full season, we would have 10 to the 77th columns. That's a very big number. So it isn't really possible to calculate the aggregate results directly, like I've shown here for 2 games across the whole season. Fortunately, however, there is another way to do it that is offered by the study of probability, and that's called the Monte Carlo method, which is basically a mathematical modeling technique that relies on repeated random sampling of a defined search space, and I'll get into what a search space is, to determine the likelihood of various aggregate outcomes. Now, in the first example, where only the blue team played, we had a search space of 2 points, meaning there were 2 potential outcomes for the season due to the fact that there was only one game, and there were 2 potential outcomes for that game. In the second case, we had a search space of 4 points, representing the 4 potential outcomes for the season. Now, as you look at this, it may not be readily obvious that there are 4 points in this search space, but what we can do is separate out the blue space into the individual points in the search space. And you can see here, and this is actually important because I'll touch on this in the next slide, that each point in the search space correlates to a column in our table of aggregate outcomes. In other words, each unique set of outcomes for the remaining games in the season correlates to exactly 1 point in the search space. And then the color of the point represents the team that comes in first place for that set of outcomes. So as we blow this up, the search space becomes incredibly large, as I've already discussed. Basically, this graph that you're looking at, I guess initially it looks like a bunch of colors, but as I said just a moment ago, each point here represents a unique set of outcomes for the remaining games in the season. Now again, this space is much larger and there are a lot more points, simply because we're talking about a whole season here and not about just 2 games that have yet to be played. So the points represent unique combination of game outcomes, and then the color represents the team that comes in first place with that combination of game outcomes. So what ChanceBot does is it randomizes the inputs for the season, that would be the games, each individual game, and as a result of all those games being played, it then determines who comes in first place, and it takes a tally of that, randomizes again. So it doesn't search the entire space that you see here, but what it does is it takes a random sample of this space, and you can see that on this graph, which shows that we haven't grabbed every single speck on this search space, but we've grabbed enough that we should have a representative sample of the outcomes in that search space. Now, this is somewhat easier to visualize if we think about the search space from the perspective of a single game. So let's say that the first game of the season is played between red and orange, and that red has a 65% chance of winning. If we cut the search space in half, with the left half representing aggregate results where red has won, and the right half representing aggregate results where orange has won, we can see that most of the sampled points will be on the left-hand side of the search space in about that same ratio. The other thing to note here is that on the left-hand side, we'll see more cases where red comes in first place, and on the right-hand side, we'll see more cases where orange comes in first place. Now, the other thing that I've put in here to show as an example is sometimes when there's a team that has a low probability of coming in first place or achieving whatever result you're tracking, a win by them actually benefits a third team. And in this case, if you look at what's here on the graph, you'll see that the number of green dots actually is a little bit higher as a proportion on the right-hand side of the search space. Now, the only element I haven't gone over is how the outcome probabilities for the individual games are determined. What the application does is it translates projected point spreads into outcome probabilities for individual games. And the way it does that is it makes use of historical data from that league. For example, if Team A is favored by 3 points over Team B, the application looks at previous results from the league to see how point spreads translated into the likelihood of the favored team or the underdog team actually winning the game. And as far as how the point spreads are determined, there's actually 2 ways that occurs on the site. First off, for user simulations, users provide their own numerical power rankings of the teams, and these power rankings correlate directly into point spreads at a neutral site game. Then the application factors in home field advantage based on historical data and establishes a point spread from there. For the site simulations, a set of computer-generated power rankings are used, and these are basic power rankings similar to what the BCS does in college football. Basically, it takes into consideration who a team has played, whether they won or lost, and how many points that team won or lost by. For example, a 3-point win over a team that otherwise has not won a game has less of a positive impact on a team's rating than would a 3-point win over a team that has won every other game it has played. So again, once the outcome probabilities for the games are determined, then ChanceBot runs the season over and over again, simulating the outcomes of the games based on the determined probabilities for each game, and then it creates the aggregate results and tracks various results throughout all the simulations. How many times did each team come in first place? How many times did each team make the playoffs? How many times did each team win the playoff tournament or win the championship of the league, etc.? So that's basically it. Certainly, if you have any questions, you can email me or you can contact me here on YouTube, and I'll try to keep the FAQ on the website updated as questions come in. And again, thanks for tuning in. See you on the site.